Hello, good morning. My name is Putrama. I'm the presenter of the article entitled Educational Big Data Infrastructure Opportunities, Design and Challenge. This study conducted at the Engineering and Vocational Faculty of Undixa to support the provision of data management infrastructure in our institution. Currently, our institution already have data warehouse infrastructure that was built several years back to support institutional accreditation. The rapid growth of the data that exists these days with its growing volume, velocity, variety, and value, as characterized as big data, are easily make up from several gigabytes up to terabytes and even more. In addition, the decision maker needs systems that can process the data easily to get analytical result of the current academic condition, be it about the student activities, lecturing as well as research, so that they can come up with better policies based on fact to improve the quality of the education and services. So by utilizing current data warehouse repository and processing with conventional technologies, it will be insufficient to process them easily in the long term. This is our research roadmap, which spanned for 3 years. In this first year, we focus on building the big data infrastructure. And then in 2021, we are going to focus on data preparation and visualization. Then by year 2022, we will perform mining based on certain requirement that is commonly needed by our institution. There are several challenges as there are not many literatures as we could find that actually expose and discuss how big data infrastructure should be developed in detail, especially for an education institution that provide a complete picture so that an institution can refer it in order to build such system. Wasn't conducted study that emphasizes the use of parallel programming models such as MapReduce and MongoDB. Meanwhile, Williamson pays attention to his study of hidden architecture of big data in higher education. A more practical result of big data infrastructure in higher education was discussed by Santoso, who proposed a design system that connect data sources, big data platform, and BI tool for visualization. Based on the finding, we found that they do not really cover in depth about the underlying technology or a more detailed ways of building the system from the ground up. So in this research, we conducted a simulation starting from only using one PC with big data platform installed inside. And we tested with some data in order to understand how it works. And then based on it, we concluded that a cluster is needed, and we tried to perform configuration by using cloud service, and at the end we build our own infrastructure on premise. During the setup using one PC, we tested with data consisting of about 12,000 records and find that using big data platform, Hadoop, the performance gap was quite high. For a query involving 3 tables, data that was imported and processed by using RDBMS only need about 1 second, while by using Hadoop platform, it need about 12 seconds. Another purpose for this test was to understand how the platform works And we came up with configuration steps that are needed to build a cluster. So during the pandemic uh, situation, we couldn't right away did the um, configuration on premise. So we was trying to perform the infrastructure configuration on cloud service. We choose Google Cloud Platform. It's actually quite convenient because we can easily add certain PC configuration that we need. However, it needs about 200 US dollar or 3 million rupiah per month, depending on the usage. And we have more concern on the data breach since the system that we are going to build is to be used for research and content data that might be sensitive in the future. So the solution is not quite reliable for us. So in order to proceed further, we implement a design that minimally sufficient for our purpose and we can gradually scale in the future. So in this design, we use two nodes as master, which will work in tandem, such that whenever one node fails, the other will automatically take place. And the rest of the node will become a data node that will perform the actual computation. However, we need to know what will be the most optimum requirement in terms of spaces that are required, number of nodes, and processing mechanism that might be needed in order to bring the data from the source system to the new one that we build. As compared with the one that was presented by Santoso et al., they only propose general design without exposing the technical detail of the underlying technology. So our design here is technically more practical, so it can be referred by other institutions based on the design that we propose. We face several challenges, such as how big is actually considered big. So we need to find out what is the minimum requirement that we need to have in order to build system for big data processing. We need to know for sure what will be the minimum requirement for one node and how many nodes that we actually need to build up a workable infrastructure. And it will be depend on what type of the data that are available and what specific process that we need to do in the future for each of the data type that we have. Another thing is that we also need to know what kind of transformation that is exactly required based on the data that we need to move from the source system to the new system that we build. For conclusion, basically to build a big data infrastructure for an education institution, a minimal configuration can be done using open source tool, and we can use several commodity species or hardware. And the technical design as presented here is usable for educational institution because the data will be quite similar among institutions and the infrastructure as per the design is quite affordable. The future work of our research will focus more on the transformation that are required, considering the characteristic of data we have and the processing requirement that is needed. That's all I have for this presentation. Questions are welcome and goodbye.